In the lighting industry, a really common protocol for controlling lights is DMX. DMX 512, which can control 512 individual channels on one sort of stream of data. And the DMX 512 is the protocol of the data, it's the way the data is laid out, but it's actually transmitted using RS485 voltage standards, and you can run a certain number of lights before you need a buffer, and you can also, if you want to split in multiple ways, you also have to use a buffer to actually isolate. You can't just like T or Y off one standard network, or it causes issues. I mean, you can get off it to a degree, but if you've got a large installation, you're basically gambling on the stability of the installation. And when something goes wrong with DMX, it's just like disco central. The lights just go berserk. So this is where these little DMX signal amplifiers come in. And, you know, you can pay a lot of money for a DMX buffer and amplifier, or you can go online and buy things like this for, well, this one costs £17.92, and I see them listed down here, £15 and £20. It's just, they seem to be a very common thing. So that comes with I think it was a 12 or 24 volt power supply. I think it was a 12 volt supply. I don't know. I've misplaced the power supply. It's been sitting in a pile of stuff, and I don't want to just pick up the first supply and say this is what came with it. But to be honest, if I was using this in a rig, keep in mind this is connected to lots of lights and stuff like that, I wouldn't want to use a generic power supply. I'd want, even if this is good inside, which I don't know if it is yet because I've not had it open, I would want a power supply from a local supplier. Like in the case of the UK, I would want to buy it from Rapid Electronics or somebody like that who would supply a certified power supply. But let's take a look inside this. Basically speaking, it takes your DMX in either directly from the lighting desk or from the sort of end of another stream, and then it buffers it up to 8 new outputs. And the question is, usually you get isolators, you get buffers. Ideally, this would isolate the data as well electrically, which means that you can actually go from one area with your lighting to another without the risk of different supplies interfering with each other, you know, current flowing down the common ground, so to speak. But if it's not isolated, it's still usable as a buffer, but only if each of these outputs has its own driver chip, RS485 network driver chip. Because if it's trying to do any cheating just by using one chip and then using sort of resistor arrays, that's not something I'd trust. So let's see what's in here. Smaller circuit board than expected. I kind of expected these just to be going straight onto, you know, maybe a board either side. Oh, well, that's quite interesting. That's very interesting indeed. I'm going to have to lift this board out of here. Is this board actually glued in? Oh, that's a bit tacky. Right. Okay, I'm just going to pause. I'm going to start. I'm going to pull this board out of here, and then we can take a look at what we've actually got in here. Oh, the circuit board is already off, so all I need to do is unplug it. Right. Okay, I'll just be back in a moment. Okay, well, in keeping with many products like this, that was a little bit weird. It's a very nice circuit board. It's textbooky. It's looking pretty good. Don't go by the colours. They don't mean anything at all. There's red, black and yellow. Now, DMX has two data lines. One's data plus, data minus. I mean, they do change polarity, but it's the phase relationship to the norm, so to speak. And then there's usually a screen wire that's sort of common sort of ground. And I would have thought it would make sense then. The positive and plus and minus data would be red and black, and yellow would be the sort of closest to earthy, groundy type wire. No, the screen wire is the red one, and the data minus is yellow and data plus is black. So just completely about as arse for elbow as they could possibly have done it. However, it all gets very interesting because with a proper isolated DMX buffer, you would have a receiver, which they've got, an RS485 receiver called Max 485. Max 485 chips are really common. Would have been nice if these had been actual, like, you know, through hole in sockets, because these are the bits that usually bite the bullet in a network, just because, you know, you get big long cables attached, the output of them, they can be quite easily damaged. But having said that, you know, I suppose it wouldn't be too hard to replace them. You've got so many outputs that, you know, as long as it didn't take out the power supply with it, you could just patch a different output if you had some spare. So if this was a truly isolated unit, it would have its incoming data buffer, which would receive the data, and then it would go through an opto-isolator, like this, an opto-isolator here. So that's the little input MAX 485 buffer, receiver chip and driver, and it then drives this transistor, which then drives the opto-isolator. All very good. And you can actually draw a line, an isolation line that goes along here, goes down like this, out like that, and then down like that. And that circuitry there is completely isolated from the rest of it, technically speaking. Apart from the two lines that go up to the opto-isolator, to these two pins here. Then the output of the opto-isolator then drives all 8 of the outputs, and each one has its own RS485 driver. And to deal with the power for that, you've got a bridge rectifier here, a smoothing capacitor, XL Semi XL7005E1 buck regulator with a choke and the little diode, just a little basic circuitry that handles. It's got quite a wide voltage range. It could theoretically handle about 5 to 65 volts in, and it can be programmed to about 1.25 to 2.5 volt output. So quite a beefy little chip, and it's obviously they've just chosen that to keep to satisfy the power requirements and give a wide voltage range in the input. But the input circuitry here also has a bridge rectifier, and MD, who really sort of knows their electronics, will be going, oh. So it just goes to a smoothing capacitor, and then it's got a 78L05, not much current required. That does limit the voltage you could put into this, because ultimately that little 78L05 is going to have its work cut out. It's powering that chip, which isn't going to be massive, but it's also driving the LED in the opto-isolator, which isn't a lot of current again, but you know, it's quite a small regulator, and it is a linear regulator. But here's the odd thing. It's being treated, it's been wired as a fully isolated unit that, you know, would normally be fed by 2 separate power supplies and would have complete optical isolation between the input and the output. Except on the bridge rectifier, both the bridge rectifiers, both the sections of circuitry are then fed from the one connector that's coming in. And that kind of defeats the isolation at that point. Because you can't really just, I'm not sure how that would go with the, I suppose it's going to give some modest separation, but it's not going to be proper full isolation. Having said that, they don't claim that this is a full isolated unit. It just says a DMX signal amplifier. And I suppose I've never really thought about it that, you know, if you're feeding, you've got one common supply, but you're feeding each through a bridge rectifier. Is it going to have some element of blocking, of, you know, a slight voltage differential between the two? I wouldn't think it would. You know, a slight voltage differential between the input and the outputs if they were connected in different zones. So it's, as a buffer, it seems to be quite competent. It has all the circuitry. I mean, to test it properly, I'd need to put it on a full-on, you know, lab-grade test system, and I'd have to, you know, do, oh God, we're just the complete range of tests with oscilloscopes set up everywhere, and signal generators and data streams, and it would get complex to test this properly, and proper loads on the output. It would be a big test. But going by the circuitry, the basic sort of layout of this, it looks like the classic DMX buffer. It's just odd. I mean, maybe they've got another version that has a different connector, a different circuit board, and it just keeps these two separate. I mean, both these opto-isolators are both these bridge rectifiers are, you know, the pins are common. So, although they've basically got 2 separate supplies, on the board they're both common at the sort of incoming connectors. It's an odd one. It's really odd. I wonder if they've just copied someone else's design and then just fed both sections from the one power source, because technically speaking they could have just buffered the output of that up and just driven all those other chips directly. It's strange. It's a strange one. But having said that, for the money, it's extraordinary. You know, if it is doing its job properly, which I don't see any reason why it shouldn't be doing its job properly, then it is a 1-to-8 DMX buffer. Not an isolator, but a splitter, buffer splitter, and that's giving a fresh, clean output for every section of the network that runs out from that point. And it's a neat circuit board, and it's just extremely cheap. It's odd indeed. Just that little bit of the power supply there just has me slightly perplexed. But yeah, it seems to be a perfectly competent looking design for a DMX buffer.